See the next question. The correct increasing order of electronegativity is. So what is electronegativity? Electronegativity means the tendency of an atom. It is not a single atom. It is for bonded atom. The tendency of an atom to attract the shared pair of electrons towards its own direction. That means strength. Electronegativity increasing order. So low atomic size elements have high electronegativities, and 17th group elements, whatever the element, 17th group elements have highest electronegativities. In these four, one option is eliminated. So in these four options, chlorine is 17th group element, that's why chlorine has the highest electronegativity. So it is not. So option C is wrong. So after that, 16th group elements, oxygen, sulfur. So oxygen is highest electronegativity. After oxygen, sulfur is highest electronegativity, and sulfur, chlorine, after chlorine, the sulfur. So B is eliminated. A and D. So if you know the second period elements, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Left to right, size decreases, electronegativity increases. Size decreases, electronegativity increases. So B, C. So B is less than C. So option A is correct. B is less than C. Next S is less than Cl. Fluorine, chlorine. Next oxygen, sulfur. When compared to sulfur, chlorine more electronegative. So sulfur is less than chlorine, boron is less than carbon. So answer A. Very easy. Next, which of the given atom has the greatest electron affinity? Which of the given atom has the greatest electron affinity? In total periodic table, chlorine is the highest electron affinity element. Next, which are the highest electron negative element? Fluorine. Highest electron affinity element? Chlorine. Next one, which of the following is not a periodic property? We know that periodic properties, shortcut. What is that shortcut? A, E, I, O, V. A means A, E, I, O, you know that vowels. A, E, I, O, U. Like that A, E, I, O, V. A means atomic radius. E is electron affinity, electronegativity, electropositivity. So these are all properties of periodic properties. So I means ionization energy. O is oxidation state. V means valency. So these are all periodic properties. So some two other properties also there. Acidic nature of oxides, basic nature of oxides. That means non-metal oxides, metal oxides. Non-metal oxides acidic nature, metal oxides basic nature. And metallic character, non-metallic character also periodic properties. So which of the following is not? So radioactivity is not a periodic property. Which of the following is correct ionic radii in angstroms? Very, very easy. Ionic radii means higher the negative charge, more the ionic radii. Lower the negative charge, lesser the ionic radii. So which one has higher ionic radii? N-3 has higher ionic radii, higher the negative charge. So next O-2, next F-. So in options, first one higher value to lower value decreases. Which one is higher value? Here 1.71. So 1.71, two options. Next 1.4, 1.36. So option C. So higher the negative charge, higher the ionic radii. Okay, note this. The next one is, which of the following pairs shows diagonal relationship? So second period and third period elements are diagonally related elements. So what are the second period elements? Lithium, beryllium, boron, carbon, nitrogen, oxygen. So lithium, sodium, beryllium, magnesium, boron, aluminum, carbon, silicon. Here three pairs are diagonally related elements. Lithium and magnesium diagonally related. Beryllium and aluminum diagonally related elements. Boron and silicon diagonally related elements. So lithium, lithium, magnesium. Its a shortcut is limca. So LIMG or linga, LIMG diagonally related elements. So next, second one, beryllium, aluminum, B alert, BEAL. So diagonally related elements. B alert shortcut. Next, BSI, boron, silicon diagonally related element. It is like SBI or B silent or SBI, otherwise border security of India, BSI, border security of India. So three pairs are present: lithium and magnesium, next beryllium and aluminum, boron and silicon. So these are all the shortcuts. Among the following, the pair of elements having same electronegativity values. So hydrogen, phosphorus, nearly same electronegativity. Hydrogen and phosphorus has same electronegativity, 2.2, phosphorus 2.1. Next, so same 1. Beryllium and aluminum are diagonally related elements, have nearly same physical and chemical properties. So beryllium and aluminum, beryllium nearly 1.5, it is 1.6. So next, nitrogen and chlorine. So nitrogen and chlorine nearly same alternativities. Nitrogen has 3, chlorine has 3.1, so nearly same. So HP, beryllium, aluminum, nitrogen and chlorine. Carbon and phosphorus. Carbon 2.5. So phosphorus 2.1. Difference is more. So answer is 1, 2, 3. Remember this point. Next, 15th question. In which group of the periodic table the element with Z equal to 120 be placed? It's very important. We know that 118 elements are present. 118th element is noble gas. After 118th element, 119 and 120 belongs to 119 is S block, that is 1A group element, 120 2A group element. That means first group, it is the second group. Which block is present means S block. So answer, which periodic table the element will be placed? Here 2. So answer 120 is placed in second group. Which is the correct order of dipole moment of BF3, NF3 and NH3? BF3, boron trifluoride. Boron trifluoride shape is trigonal planar. So dipole moment 0. If the central atom has no lone pair of electrons, the dipole moment is 0. Here mu is equal to 0. Next, NH3 and NF3. NH3. Both are pyramidal shape, but when compared to hydrogen, nitrogen more electronegative. So electrons are shifted towards nitrogen atom. Dipole moment towards nitrogen atom. Here lone pair of electrons are present. The dipole moment shifted towards lone pairs. So total dipole moment is upward direction. So more dipole moment, mu greater than 0. So in NF3, here also dipole moment greater than 0, but when compared to this one, dipole moment decreases, because when compared to nitrogen, fluorine electronegativity is more. When compared to nitrogen, lone pair of electrons attracts towards upward direction. So nitrogen the dipole moment due to lone pair of electrons is cancelled with NF bond, one of the NF bond. Remaining two NF bonds are downward direction. So net dipole moment is downward direction, but when compared to ammonia, here all moments are in upward direction. Here only two NF bonds are downward direction. So NH3 is greater than, dipole moment of NH3 is greater than dipole moment of NF3. Mu is equal to 0 for BF3. So BF3 is very less. Next one NH3, higher one NF3. So answer D. Sorry, answer C. NH3 is higher than the NF3 than the BF3. So not this one. Okay, once see this. IUPAC names for elements atomic number greater than 100. IUPAC names for elements atomic number greater than 100. So how to write? If the number is 0, root word is nil. When you write the atomic number, when you write the IUPAC number, when you write the IUPAC name for an atomic number, so if 0 is present, then you write nil. 1 is present, un. If 2 is bi, 3 tri, 4 quad, 5 pent, 6 hex, 7 hept, 8 oct, 9 n. If 10 is there, again 10 means 1 0. 1 means un, 0 means nil. If 1 1 8 is present, 1 means un, again 1 means un, 8 means oct. Finally you write m. IUM. For every element, last you write IUM. That means IUPAC name ends with IUM. So un octium. If 109 is present, 1 means un, 1 means un, 0 means nil, 0 is nil, 9 means n, enn, n. Finally you add IUM, unnil and m. Like this, the question is here, what will be the IUPAC symbol and name for the element with atomic number 123? So 123, 1 un, 2 bi, 3 tri. Finally you add em. If I is there already, then you not write again I. Then you not write again I. So try em, IUM, un by trium. So how to write the symbol? In UN, first letter U, capital letter. So next in by, first letter B, small one. Next also small, try. So T, U, B, T. So U, B, T. So U, B, T, un by trium. So answer is C. So what is the symbol for unoctium? U, U, O, capital U, small u, O, unoctium. So 109, U, N, nil, N, and U, N, E. So U, N, E. Like this, very, very easy. If you know the root word for that numbers 0 to 9, then very easy to write IUPAC name and IUPAC symbol for 100 above, whatever the atomic number. So next question, also see. The symbol of an element is UNG. U means un, again N means nil, E means NEM, un, nil, NEM, un, 1, nil, 0, NEM, N means 9, 109. So answer 109, B. Very, very easy. Next one, basic oxides or metal oxides. Basic oxides means metal oxides are basic in nature. Maximum 1A and 2A group elements are basic in nature. So Na2O, BaO, MgO, CaO. Examples, some examples. Acidic oxides, non-metal oxides, SO2, P2O5, CO2. These are the examples of acidic. Next, metalloid oxides. They are having amphoteric in nature. That means they react with acids and they react with bases. They are called amphoteric oxides. Example, how many of the following oxides are amphoteric? So according to this, how many of the following are amphoteric? BeO, amphoteric oxide, BeO amphoteric. So BeO amphoteric. Next ZnO amphoteric. Next Sb2O3 amphoteric. Sb2O3. So these are only amphoteric oxides. So answer is B, 3. CO is neutral. Next CaO, second year group metal oxide, basic. SO2, SO3, acidic. So next, what is the correct order of atomic or ionic size? We know that left to right size decreases. So here we know that third period elements, scandium, titanium, D block elements, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. After copper it is third period. Next fourth period, yttrium, D block elements, yttrium, zirconium, neodymium, molybdenum, technetium, ruthenium, rhodium, palladium, here silver, cadmium. So if you observe copper, silver and zinc, top to bottom size increases. So highest ionic or atomic size is silver. So you eliminate option C. Next, copper to zinc ionic size or atomic size decreases. Left to right in periods, atomic or ionic size decreases. That means Zn+2 has least atomic size. So which one has Zn+2 least atomic size? So Zn+2 here. So option B. Otherwise, when compared to Cu, Zn has least atomic size. When compared to Cu, Zn has least atomic size. So this one wrong. So compared to B and D, if you compare Cu and Cu plus, Cu plus size is less, Cu size is more. Cu plus size is less, Cu is more. Zn+2 size is very less because higher positive charge and isoelectronic species. So answer B. So very easy, don't confuse. Here I will discuss some important points about Mendeleev's periodic law and Mendeleev's periodic table. So what is Mendeleev's periodic law? We know that Mendeleev's periodic law means the physical and chemical properties of elements are periodic functions of their atomic weights. That means in periodic table, all the atoms are arranged in the increasing order of their atomic weights. So at that time only 63 elements are known. The first point, very important point, is at that time of periodic table, Mendeleev's periodic table, it is also called as a short form of periodic table, only 63 elements are known. So next one, Mendeleev periodic table is classified into two types. That means horizontal rows and vertical columns. Horizontal rows are called periods and vertical columns are groups. That means in Mendeleev's periodic table, 9 groups, 0 to 8 and 7 periods are present. So next important point, in these 3 transition triads are present. First one is iron, cobalt, nickel. Second transition triad is ruthenium, rhodium, palladium. Third one is osmium, iridium, platinum. So again, a very important one. Mendeleev left some gaps in the time of his periodic table. So they are named as Eka boron. Eka boron is also called as next scientists find out scandium. Next Eka aluminum. Eka aluminum means gallium. Eka silicon. Eka silicon means germanium. So very important one. Next, Mendeleev corrected some atomic weights of elements. So those atomic weight of elements are corrected. It is the question. So beryllium, indium and osmium. Beryllium, indium and osmium corrected atomic weight elements. Which formula used in this corrected atomic weight means atomic weight is equal to equivalent into valency. So next important question is which of the following are inverted pairs or anomalous pairs? So what are inverted pairs and anomalous pairs? That means some elements with higher atomic weights were placed before the lower atomic weights. Actually first lower atomic weight, after higher atomic weight. So it is disturbed some elements. So that elements are called inverted pairs or anomalous pairs. Very important, 4 inverted pairs are there. Argon, potassium, arc, shortcut is arc, argon, potassium. Next Coni, cobalt, nickel. Next tellurium, iodine. Final one, thorium, protactinium. Very, very important. Next one, position of hydrogen not clear at the time of periodic table. Very important, no place for noble gases. Isotopes are not included. So finally, important formula for electronegativity. Electronegativity was measured by using Pauling scale and Mulliken scale. Here very important one is reference element to calculate the electronegativity in Pauling scale is hydrogen. So hydrogen electronegativity has taken as 2.1. So next Mulliken scale. In Mulliken scale, electronegativity is calculated by using ionization energy and electron affinity values. Different formulas are there. Please screenshot here. So next electronegativity of Mulliken scale, electronegativity of Pauling scale relation. So electronegativity of Mulliken scale is equal to 2.8 times of electronegativity of Pauling scale. Very, very important. So note this one. Thank you.